Hello, everybody, and hello, Aaron and Josh.
G'day.
Um,
Hey,
yeah,
everyone.
hey, good to be back on the stream. Our third dev in the shed that's usually here every week, Matt, is running a little bit late today, so hopefully we'll see him a bit later. But yeah, how's everybody doing? Let us know in the chat how everybody's going. Aaron, myself, and Josh are in Melbourne, and it is wet today. So I was actually in the city, so on the way into the office, and I was just absolutely soaking wet. Trying to get into the office. It's been really fun. Is it still pouring down at your places, Josh and Aaron?
It is, and it's definitely Arctic. I am absolutely freezing. I'm not looking forward to another Melbourne winter.
I went out to my shed to broadcast from my shed, and everything was snap frozen. So came back into the warmth of my office.
Yeah, well, I mean, that's probably this week was probably all been a little bit not shed-y. I'm actually in the office today, so in the Amazon office in Melbourne, and so yeah, I got some customer meetings this afternoon. I wasn't able to stream from the shed, but Josh has got a couple of like shed-like toys, IoT things that he's going to show us today. But for anybody new to the stream, devs in the shed, we like to build things. We're have a background in development, so we're always tinkering with code. But we also like to actually physically build things and put some things together. You've been following us for a while. You've seen a number of our different like IT solutions, and maybe we should go back to that. One of the earlier ones, we did a session on how to like measure the resistance of a resistor by reading the colors on the bands and so forth. But yeah, that's what we do. Aaron's one of our senior principal solution architects at AWS, and Josh is one of our solution architects within the worldwide retail sector. And you know myself and Aaron pretty well, but maybe I'll like let Josh introduce himself and talk a little bit about his role and what he's sort of seen in his time here.
Sure. Thanks, Paul. So Josh is my name. I'm part of our worldwide specialist industry team for retail. I've been at AWS for about 5 years now, so I've seen quite a few things now. I can't work out if it's gone by in an instant or been quite a long time. But my role is to help retailers adopt AWS technology in a big way. So everything from e-commerce transformations, bringing digital technologies into the store, building machine learning and data platforms, or basically helping use different data and technologies to really transform customer experiences or optimize supply chains or whatever the case may be. So we've got a couple of examples today of where we can use digital to kind of merge the lines between physical and digital. So we're going to show you some of these demos today.
Yeah, awesome. Matt's just jumped on. We just did the intros, talked about, introduced Josh, and then I think Josh and one of our audience said that I think I was making some static noise there. I hope that's fixed now. Like, let me know if that's fixed up. I think it is. Yeah, cool. Thanks for that. Summit was like a ton of fun, wasn't it, Josh? Like, it was busy. We set up a lot of stuff, and it was like really hectic.
It was very hectic. I slept for 3 days after that, but it was a good event and definitely a lot of fun.
Yeah, I think that when you, for anybody that's been to either AWS Summit or reInvent or one of our big in-person events, the stages, the setup, the booths, like they're well presented. They come together. Being behind the scenes and seeing the production crews that work on that, it's actually like really eye-opening. Like how many cables we have behind the scenes, running cables underneath the dashes. The flooring, all this stuff to make sure that our demos kind of work on the day, making sure that setting up on specific machines. No, we Sharon, it was just you. It was a lot of fun, and I think like the customer experience booth was a great one, right? Like it went down really well. Had a lot of people coming over, looking at some of those solutions and demonstrating, some of the technology that we're seeing being rolled out into the retail space, like being able to see it, touch it, feel it, and see what it looks like. There's for people that might not have been aware that we have this like just walk out technology where you can effectively tap yourself into a shop, walk around, pick something off the shelf, and then just be able to walk out the other side of that. Like that's pretty amazing technology. Being able to see it and play with it, even in a proof of concept environment like that we had there, has been like really, really fun.
Paul, I just have to echo your comments there. Seeing the small army of people that probably work, a 10 or 14-hour day to put a lot of that, the production stuff together, it's pretty crazy, definitely eye-opening, and a lot of appreciation for the work that they do, because I know how hard we found it getting everything set up, but try doing that at a massive scale, right?
Yeah, absolutely. So today, Josh is going to show us a couple of hands-on demos and give us a bit of an oversight of those things. So maybe for now, we'll hand over to you, Josh. Do your intro, and once you've got your screen shared ready, I'll pop that up, and I'll share some of the links into the audience as well, so you can participate and see those things in real time as well.
So maybe what I'll do is I will just let me just give a quick intro to some of the demos and kind of trends that we're seeing before we jump into actually showing you how the demos work. So Paul, just let me know when you got the screen up.
Screen's up now, Josh.
Awesome. So I think, what we really tried to explain at the ANZ Summit with the Future of Customer Experience booth was really to show how technology is being used in a physical sense. So the types of technologies that have been brought into a more traditional kind of, physical fitting, where we use things like augmented reality or IoT or, computer vision type technologies to really provide a differentiated experiences to customers coming into, a physical store. Some of the things that we're seeing, right, is we're seeing a lot of the traditional physical retailers, the retailers that have just been bricks and mortar forever, really starting to adopt and embrace a lot of this technology. So we're starting to see things like, virtual try-on, or we're seeing even like in barbershops and other types of, service-orientated retailers starting to bring things like augmented reality for haircuts and beard styles and hair colors, trying on different clothes. We're seeing a lot of personalization creep into the space as well. So, when you walk into a physical store, being able to, be recommended other products from a retailer's range that might go with the products that you're already wearing or looking at. You would have seen in the media as well, we've introduced a physical store in the US, as Amazon Style, we call it, which is actually Amazon's take on a digitally experience-based store for fashion retail. So it's been really interesting to see how that's come together as well. The other exciting trend I think that we're starting to see is digital pure play retailers. So, think the e-commerce fashion giants of the world that have always been online only. A lot of them are actually starting to create their own physical stores. So break into that, bricks and mortar retailer for the first time. And they're starting to really create these, highly digital orientated experience-based stores. So we kind of call it like retail entertainment, which is, you can walk in, you see these highly curated collections of clothes. You see a lot of, unique experiences and, stuff like that. So it's really interesting to see. The first couple of demos that we're going to show you is really orientated at removing friction from a customer journey. So if you think about yourself as a customer, what are the most painful things for you when you actually go to visit a physical store? For me, it's like going through a checkout, or I remember once, I won't name any names, but I did a click and collect order at a retailer and went in, and this was during the kind of, COVID and restricted trading times, went into the store to pick up the click and collect order. And I ended up waiting, I think it was 70 minutes to get that order for one item. And it took the store, I think, 2 weeks to actually prepare the order so that it was ready to pick up, which was just mind-boggling. And it was actually harder than just going to the store and picking the item off the shelf and then going to purchase it. So there's a lot of, these different friction within the customer journey that a lot of retailers are looking to remove. So that's what our demos were orientated around. So the first one is, this one was probably my favorite one of the three that we did at Summit, but we're only going to show you two today, I think. So my favorite was actually the buy online, pick up at curb type of solution. And basically what this solution consisted of is a location-based demo where we can use Amazon location services to actually track where a customer is orientated by their physical device, create a geofence for the actual store. And whenever that customer enters that geofence or crosses the boundary, actually send or make decisions in real time based on that customer's physical location. So in this example, where we'd send an alert or actually show that that customer there's an order ready to pick up for that customer. The second part of it was the actual buy online, pick up at curb part of it, which was how do we use something like computer vision through, and in our case, it was Amazon recognition, to actually recognize that the customer has arrived at a at a designated car parking bay at the store or whatever the case is, and actually alert the staff to bring out that customer's order without them actually leaving the boot. Without leaving the car. So this type of technology is actually used by Amazon Fresh in the US for grocery pickup. So it is starting to become a little bit more mainstream.
I guess the idea there, Josh, is that if you're made your order somewhere, usually you drive in, you find that that specific car park that you need to go, you park there, pull out your phone. On your phone, you say like, I'm here, either like SMS it or use their online app or whatever to do it. At that point in time, someone inside the store has been triggered to say, yep, we should go ahead and grab that order and get that ready. And that's where you incur that specific wait, right? Like, if you want a frictionless experience, it's like, well, I don't really want to do any of that. I just want to roll up, go into that car park and have someone just bring me my item so I can just reverse it and go.
Yeah, definitely.
I noticed on my last trip to San Fran that there's actually a lot of the Amazon Go stores around that, like for me, that was amazing. Like you walk in and, you pick up the stuff and you walk out. As long as you've got an account, it knows who you are. And, it's pretty cool. Like along the lines of what you're saying with Amazon Fresh and the like I'm seeing, obviously they're not getting into Australia as fast. They're mostly in the US and the UK, but I'm seeing them really, really starting to like pop up in really unique places all over the US and the UK. Like it's really starting to take off.
Yeah, it definitely is. I'm just going to get another link up that I've forgotten to pre-organize, just so we can see this demo in action. So if you just bear with me for one
Is this the
second.
back dashboard, Josh?
No, this is the retail demo store. So for anyone on the team that hasn't seen this before, we've actually got this great retail demo that you can actually deploy in your own accounts, called the Retail Demo Store. And basically what it is a mock store that allows you to demonstrate or experience all of the different technologies that AWS have in the retail space. So, you can see some examples of Amazon Personalize and things of that nature. And I'm getting a couple of errors, which is probably my fault for not pre-checking. Well, that's okay.
I've shared with the audience the dashboard and this would be the dashboard that you would have the internal staff that would be looking at to determine whether or not somebody has entered their car park to look at. So that's the specific, that URL that I shared that ends with cloudfront.net. And you all should be able to like open that and see in real time as that changes. And what we'll be doing is mimicking what it would be like for a vehicle to turn up into that specific car park. That was one of the demos that we had running specifically at reInvent, and to mock that, obviously we couldn't have a real car, but we had a 3D printed supercar thing there, with a specific number plate, right? And like I've got that photo of me like holding that, and the number plate was Summit. I'm sure you've got it somewhere around your house, but basically the idea was, as soon as one of our cameras that is looking for the car entering that car space, there it is. We would be doing like running recognition and looking for specific texts that match. Now, if you have a registered profile with like Acme Retail, and your number plate is registered to Acme Retail to your like account profile, then once your vehicle has entered that car space, the store then can be automatically triggered to say, hey, Josh has entered the car park. This is the number plate of his car. Go and grab his order and go and deliver it to his car.
Paul, I've just put a link in the chat. Check if that works for me, because it's not working for me. Didn't pray hard enough to the demo gods, obviously, but we can skip straight to the.
It is definitely working for me.
It's working for me. That's welcome to the retail demo store.
Yeah, just see if you can sign in. If you click the sign in button up the top.
Yep, done.
And if you choose, actually, I might try Safari. I've got to try like 3 different browsers to get this working. There should be something down in the bottom that says use default user, like Lana Williams or something.
We got to sign in the
No.
first time.
I just got to sign in, username, password, forget password, create account.
Okay. Yep. Let me. Okay.
We could
no,
probably
Safari-
Skip
Safari works,
login for
Safari
now.
works. Safari works. It's all good. We've saved it.
You can do the skip login for now, so you don't have to log in.
No, it's all good. So what we're going to
We've got to go on.
do,
We've got to go on. So what's the first demo that we're going to show, Josh?
I'll go through it in just a second.
Yeah, Coombsy. Yes, Acme company is a really big company actually. Like many demos run that.
Yeah, for anyone that's seen Roadrunner, it's a big company. Okay,
So, should we bring up your screen?
Yeah, if you don't mind.
Great.
The actual term Acme, just for a sideline, is the point at which something is at its best or most highly developed. So that makes perfect sense. It's a company that is at its best.
Yeah, I don't know if my broken demo lives up to that standard, but we'll see. Okay, so what you can probably see on my screen now is two screens, right? First of all, we've got the retail demo store. Now, what this is for anyone that hasn't seen it is basically just a really mock kind of demo store that will allow you to demonstrate all parts of some of the technologies that we have. So things like Amazon Personalize, how you actually have personalized product recommendations provided to you, similar items recommendations, things like real-time user segmentation with Amazon Pinpoint, how we use like geofencing with location, which we're going to show you. But basically, this is like a holistic demo where you can experience all of these different demonstrations. We've actually built some integrations into other parts of the products or other things that we're about to show you. So if you want to experience this for yourself, you can go to the Amazon GitHub page and download this kind of demonstration for yourself. So the first thing we're going to do is we're going to demonstrate like how Amazon location services can be used to actually react to a customer's physical location. So in this case, I'm logged in as myself, and I'm going to place an order. It's for a camping lamp because apparently I'm going to go camping in this terrible rain. I'll add that to cart. I view my cart, and I've got an office chair too. Okay, that's fine. And we're just going to check out, and I'm going to select pick up at store, and put a phone number. It's not a real phone number, so don't worry too much. Great. So now I've purchased that item. So now theoretically, if I've set this up correctly, if I actually, as a customer, and we've just emulated it here, but imagine you're driving around in your car, and this blue box here indicates the store's kind of geofence. If I actually hit this button here, all this does behind the scenes is there's a series of GPS coordinates that like emulates my position as I'm approaching the store. And you can see through the magic of the demo gods, we've actually identified that when I've crossed that geofence, that we can send a real-time notification to the customer, which is also me, obviously, that I've got several orders that are ready to be picked up. So in this use case, you might want to offer a discount for coming in to collect your order quickly. You might just want to remind your customers, or you can also build an experience around knowing where that customer is. I'm actually working with a global, a very large mall provider that is looking at building a whole experience around knowing that somebody is going to come in and pick up an order. So if you imagine, like if you know that somebody's coming in to pick something up, like maybe offer them discounted movie tickets, or send them a notification that there's a restaurant reservation available at their favorite restaurant or something like that. So knowing some of these data points can be really, really powerful to build a holistic customer experience.
Especially when so many of the retailers, and I'm sure you see this, Josh, they're like, a brother and sister companies, right? So one company is linked to somehow to another company. And so that might mean, I don't know, you're going to pick up some sort of car part, but at the same time, because there's a partner company that is also selling, like, I don't know, Home Depots, you can be alerted to say, hey, this shovel's on special today or something.
Definitely.
You might be interested in it.
you raise an interesting point. Car servicing is a big one. So a lot of malls and things like that are now looking at saying, well, hey, why can't I provide a value add service like car servicing, where I know that I'm going to keep a customer waiting around, while their car's being serviced, and they can build a whole like entertainment experience around actually entertaining that customer while they're waiting for their car. So that's actually a really big one. Now, the next part of this demo is, imagine that I've created this order, right? And I've alerted the customer that their order is ready to pick up. How do I create a frictionless experience for actually allowing this customer to come in to pick up their order, and for them not to have to go through the hassle of getting out of the car, going and queuing up in store, and all of things of that nature? A lot of retailers now are starting to do things like, okay, push a notification or push a button on your phone app when you're here. But in this example, we're going to use computer vision to actually create a more frictionless experience. So just to walk you through this really quickly, at the summit, we actually had an IP-attached webcam set up in a little concrete bollard that was pointed at a car park. The 3D printed car, which Paul mentioned before, with this lovely summit number plate on the front of it, we actually pushed that up to the camera. And what we would do is we'd actually use Kinesis video streams to stream all of those frames in real time into the cloud for processing, and some Lambda functions orchestrated by a step function to actually read the stream, process it, recognize that there was text or text available in that video stream, check to see if that text matches an existing reservation for that date. And then if there's a match, actually go and send a real-time notification to both an assistant and a customer. So we're just going to show you how that works now. And obviously we can't send you, we can't use a real car. So what we're going to do is, Paul, do you want to bring up the dashboards actually?
Yep. So I'll reshare that URL as well to people. Do you want me to bring it up on my screen?
Yeah, if you don't mind. I've got so many windows open here, I'm getting very confused.
Okay. All right. I'll bring that up.
Okay, let me just check. If not, I can do it. It's fine.
It's okay. I got it. That should be it now. I think we can see it. So this is the screen that the operator at the store who was going to deliver that.
Yep. Oh, can you bring up two windows at the one time?
I have to share my desktop, and it's not prepared enough to do that.
That's okay. So maybe if everyone's got that dashboard open on their screen, maybe what I'll do is I'll share my screen and show you the actual steps, because I think that's probably a little bit more. We can bring the screen up later. So the first thing that we need to do is we need to create a reservation for a reservation that we're going to match to. So in this case, if my computer stops lagging, in this case, all we've done is we've created an API here, and we've got an API key, so we'll change that later, so don't worry too much. And we're going to just create a reservation with the number plate, the name, and the phone number, and the date that we're going to match an order to. So now that we've created that, we're pretty much good to go. The other thing we're going to do is just quickly launch the Amazon step function execution. I don't know why this is lagging so much. And all we're going to do here is just create an invocation of the step function that actually runs all of the, the checking and processing of that video stream. So you can see here, we've just got an invocation of that function running here. And I'll stop the last one so I don't get two notifications. So if you imagine a production sense, we'd just have this running all automated, obviously. And then the last thing that we're going to do is we're going to actually just call a video that we've pre-recorded, because again, we don't have a car. And we're actually going to stream that in real time to the cloud. So you can see here via Kinesis video streams, we're just sending the frames. And then what you should see here, and I say should, is you can see the video actually appearing in the Kinesis video streams console. So this is actually just the frames that are being streamed in real time. Now in this step function, you'll see that we're doing a loop here that basically processes the stream. And if I shrink this down, we can see the inputs and outputs. We can see that the steps in this, when we detect that there's text, we change this to true and then pass it to the next step in the step function. And once that's done, we'll actually take the text and then we'll pass it to the function that checks to see if there's a reservation. And you can see here that it's picked up the summit text, and then we'll actually go and match that to a reservation. Now you can see here that we've actually matched it against a user ID, the date, time, the number plate. This is a really important one. So if the customer's already picked up their order or that we've detected them arrived before, we don't want to process that again. So we make sure to change the detected parameter to true, which means that if that text gets picked up again and matched against that same order, then we don't go and send duplicate notifications. So you can see here, actually on my phone, I've got two notifications at the bottom here. One saying, as a staff member, please go and prepare Josh's order. And then the second one is for the customer saying, Josh, your order is being prepared. Obviously, for the demonstration, I'm receiving both text messages there. Now, if you see the dashboard, hypothetically, it's been updated.
But maybe that order was detected already, Josh. So maybe go back into DynamoDB and reset that. So the backend data store for those specific orders that are coming back in, for anybody that's watching, that is like DynamoDB. So in DynamoDB, you can go ahead and change those items, and this is what we're doing for the demo store there. So it was the way we had this operating was we had a specific set of reservations. It doesn't really matter whether you've got one or many there for that specific demo. But as soon as the number plate was detected, that specific number plate linked to that specific person, step function was invoked, text was determined as detected. Because there was text detected, we did a lookup to check whether that specific number plate was registered to a profile. If it was registered to a profile, then the backend operator gets some sort of like notification, and that might be like up on a really big board that people are sitting there working to. They might have an app that's running on their phone, and they get like a vibration alert, so that in the meantime, while they're doing something behind the store or whatever that might need to be, that they get notified so they can go out and do it. So you can be very like efficient and maximize your time and the staff's time that you're doing, as well as providing like the customer with notification that, hey, somebody's coming to the store, they're in the car park, let's get it out to them immediately.
So you can see there that the number plate has been detected and the dashboard's been updated. So hopefully that appeared on your screens as well. And then, of course, we want to dismiss that and make sure that order's been marked as picked up. So that's kind of a quick summary of the buy online, pick up at curb capability and how AWS technologies can be used. So yeah, it's a big trend that we're seeing, especially during COVID times. And a lot of retailers are investing in this type of technology. So if you're a retailer, come and talk to us.
Maybe before you move on for a second, we'll just go back and talk about like what we were using, like how we were connecting Kinesis to that. So there was a number of different implementations that we had. So to make this demo work, like in this specific instance, we had like a machine that is capturing inbound video. What we did for the demo is we had a webcam with a big long extension, and that webcam was capturing the input, and we were using the Kinesis video streamer to capture that input and continually push that up into AWS. Now, we also had some issues on the second day with that wasn't working directly from the webcam. So we used a network-based IP webcam to do that. And we were streaming directly from what's the protocol called? RSTP?
RTSP, yeah, real-time streaming protocol.
Yep. So we were streaming directly like over the network, directly into AWS. And that way you can have like that camera like standalone on your network. You can have the authentication. Yeah. You can have the authentication set up for that specific cam and pass that information directly into Kinesis. And that video will be going up in Kinesis. Now, obviously, you would be considerate about like the bit rates and the frame rates that you're sending up there. We didn't that as a concern for us. But you want to think about those sort of things, how much data you're pushing up to the cloud and what you're looking through, and that was continually being inspected via that step function in a loop. The demo that we just did then to mimic that, Josh did the exact same thing, except we just force played the video rather than having the camera read the back of the number plate.
Yeah, so I mean, we probably should have played the video just to show you guys, but I think the important thing here as well is that you would have heard of this thing called like local inference or inference at the edge, which is gaining popularity for many of the reasons that Paul basically just mentioned. As you process more cameras and more streams and more data, it becomes increasingly difficult to send everything or enough data into the cloud for processing. So in our case, we've been able to leverage Amazon Rekognition, which has made the inference really easy to pick up the text on the number plate. But of course, if you times this by 10,000 cameras or something, it's obviously it's going to get exponentially harder. So in some cases, what customers, especially retailers, are now looking at is leveraging things like Amazon Panorama and other local-based devices that you can put into stores that can run similar machine learning models or similar types of inference directly in the store to mitigate the need to send all of those video streams up into the cloud. What we do find, though, is that processing the metadata and actually orchestrating a lot of the the events that happen is still very much a good use case for running in the cloud. Although in the next demo, we're going to show you how you can do that locally as well.
Cool. Yeah, there's a couple of people that are saying, so I know, Josh, that we were specifically talking about the Sydney Summit, but I'm pretty sure you were at one of the other summits as well. And we got someone from the audience saying they're from Atlanta and they were questioning whether or not we were at Atlanta.
No, it wasn't at Atlanta, but there may have been a similar demo run. I'm not sure. Potentially.
Yeah, well, once you see the next piece of like IoT equipment that Josh has put together, you'll see why it was like we couldn't actually ship that piece over. We probably would have had to go on a couple of weeks earlier and prepare the actual device. But yeah, like you'll see that in a second. Josh will bring that up shortly.
Okay, maybe I'll do that now. So the next demonstration, we've actually run a couple of years now, but it's something that has been pretty popular just because of the hands-on nature of it. So I'm going to skip out of some of these things. So the next one is a demo that's been put together where we use, it's basically a smart cooler. So what a smart cooler is basically our interpretation of, or I guess, example of how friction can be taken away from something as simple as a vending machine type experience. The whole idea here is that we want to demonstrate, let's say frictionless, checkoutless experiences for customers using technology. So, very similar to what a Just Walk Out would use. Obviously, their solution is a lot more advanced than what we're going to show you, but the philosophy is the same. How do you remove friction from a customer journey? So what we've basically put together is a little bar fridge that leverages IoT functionality and a few physical devices to actually orchestrate how a customer purchases something from that fridge. So basically what we do is we've created an authentication and method where we can scan a QR code, enter our credentials and hit the button. Of course, if you've got a customer app or something like that where you're already authenticated, then great, then that would be even more seamless. We actually then trigger a magnetic lock to actually unlock the door so you can physically access the inside of the fridge, which is this part here. Then the customer will actually reach in, grab something, pull it out, close the door, and we use a series of sensors to actually figure out when the door is being closed. And then we take an image of the inventory that's in the fridge. We send it to a SageMaker-based object detection model, and we work out what has actually been taken out of the fridge, similar to what we would do with Just Walk Out, where you grab something out of the store and then just walk out. And then as soon as the door is closed, we actually would send you a bill or a receipt for whatever you've taken out of the fridge. So to do that, this is kind of what the overall architecture looks like. We've got a couple of serverless websites here that manage the user interface side of things. So displaying when the customer will be able to open the fridge and providing the prompts to actually tell the customer when to interact. We've got a little webcam, USB webcam inside the fridge that will look at the inventory. We can have red or green LED strips or indicators to show the customer like when the fridge is open, locked, or locked or open. We have a door sensor, which is just two little magnetic strips that will basically continuously read whether or not the door is open or closed. And then, of course, the magnetic lock that I mentioned. Now, to make this all work, we use a Raspberry Pi that's running Amazon IoT Greengrass, which is basically a IoT, what would you call it, Paul? Like an IoT software that allows you to run local-based Lambda functions, create local groups of IoT hardware, push over the air updates, manage policies, all sorts of things. But in this case, what we've got is a series of local Lambda functions that we use to process the authentication, the door sensor, and the actual purchase. And we use MQTT topics to actually orchestrate when those functions are fired. So every time something happens on the fridge, we publish to a topic, and then those Lambda functions are fired depending on the events that come through to a topic.
I think, like Josh, when you talk about like Greengrass, and for people that are, maybe wondering like, why would you do this? Like, could you go to the Raspberry Pi and just write some specific functions, put the model on the Pi, interact with anything in the cloud with over REST endpoints? Like, yes, you could totally do that. And the benefit of using like our solution or the Greengrass solution is that you have this control plane that exists with the rest of the infrastructure. You're taking advantage of the ability to deploy in the same mechanisms, to be able to look and version control those deployments, to have your permissions set up, like run all the way through, so that you can have those Lambda functions that might be running on your local device on the Pi have the correct roles to be able to interface or interact with specific services within the cloud as well. So you have that disconnected platform, but it's still managed by the same control plane.
A good way to think about it is, imagine you were writing individual scripts that would run on the Raspberry Pi. How do you actually go and manage deployment of those scripts and versioning of those scripts and updates across maybe 1,000 devices? It becomes very, very difficult. So what Greengrass allows you to do is actually orchestrate and deploy consistently across very large fleets of IoT devices. So it's not just about the fact that we're running one Raspberry Pi, but imagine we had 1,000 of these out there. How do we actually go and manage deployment to all of those different devices? So I think that's a really important part of it that becomes very obvious when you're running IoT-based solutions in production. It becomes pretty difficult pretty quickly. Now, this last function is probably...
Josh, there's one question. So Jake Programming just asked a question. Does the Raspberry Pi have to have AWS access keys deployed onto it? So maybe just go through like the authentication mechanism between Greengrass and how you grant authentication to Greengrass.
I almost can't remember now. It's been so long since I put it together. However, I believe we use certificates for the most part. We have to pre-authorize and get the right certificates installed. And I can't actually remember if we put keys on the device or not, but I'm not sure we did.
I would assume you would still have for the purchase Lambda, you'd be using an API key to talk to the API gateway endpoint.
I think that they're specifically talking about like access keys, access key and secret key. So how do you originally configure that device to be able to speak into the cloud?
So I know that when we deploy the Lambda function, we install all of the certs, and we authorize that in the... You have to generate a specific certificate pair when you set up the Greengrass device. So when you actually see this in the... Let me bring it up here. When you bring it up in the Greengrass console, you'll be able to see the devices. Groups, where's groups? I've got to remember if this is in this account or somewhere different now.
Are you in the right region as well?
Yeah, I'm not sure. I can't remember where I've put it. I've been just hot plugging the device because it just works now. So
while you're getting that going, so maybe to sort of help answer that question, yes, like you would set up like a specific role, because that role needs to provide like access a user, right? A user that comes under a role, and
Roles-
that user has like
Roles definitely.
Yep, and that has a an access key that provides that device to be able to communicate and set up and configure Greengrass. All the communications are done over those secure channels, which is what Josh is going to go into when you look at the specific. So it's like MTLS certificates. So certificates are generated to enable secure communication between your device that's on premise and the cloud, and the authentication on that channel is over MTLS.
Okay, so I found the group here. And so, Paul, have you got my screen up here?
Yep, we've got it up.
Okay, so generally, I found the little device creation here. So when you set this up, you generate certificates that will basically authenticate the device into into the Greengrass group that you're working with. And then when you actually manage that group, so you can see here, I might have, see, you can see I've got a few different groups here. But then when you actually create this group, you can actually run deployment. So I might have 1,000 different devices in this group here. And then every time I do a deployment, I can push a new version of code to all of the devices in that group accordingly. And you can see here, I think this is where we get the certificates, and we can roll the certificates if we want to. And then you can see here, we can actually specify what types of roles and users that the Lambda the Lambda functions on the device actually run and use. So if I come up to the groups here, and I should be able to show you the Lambda functions that we've got deployed. So we've actually got these 3 Lambda functions deployed here. And when you click on one of these, you can see that it's just referencing, they've got the environment variables and the resources that it's going to use. But this actually references a real Lambda function that you would create pretty much just as normal. So if I go into the Lambda console, you can see that this Lambda function has just been deployed as normal. So if you think about all of the ways and patterns and mechanisms that you have to package and deploy Lambdas into AWS, the great thing is that for Greengrass, you can leverage basically the same mechanisms, but then actually run those Lambda functions directly on Greengrass. So you can see in here that we would also have the roles and permissions associated with this Lambda function. So I've got the resources, the trust policy set up with Amazon IoT, and then obviously with the relevant permissions that it needs.
And so, this Lambda function, if you were to SSH to that Raspberry Pi, you would see the code, like this code and this Lambda function is running on that device.
Yes, so you can actually see in the Greengrass core SDK that gets deployed and the software that gets installed, you can actually see where the Lambda packages actually get uploaded and executed. Cool. Okay, so I think we've explained that. We got up to the purchase function. So probably the most interesting part of this is obviously how we do the inference. So what we do here is we've used SageMaker to train an object detection model. There's actually a bit of a process behind this where we had to create a very large training set of data. Paul, do we want to show that? Do you think we have time or?
We'll go through the demo and then we'll show what we do with the training data, I think, at the end, because that was pretty interesting, coming up with a mechanism to provide a lot of training data without having to take a lot of photos.
Yeah, for sure. Okay, so maybe we'll skip straight to the demo. So what we're going to do now is demonstrate to you the fridge. So Paul, if you bring up those 2 console windows.
On your screen?
On yours, if you don't mind, because I have to run downstairs to the fridge.
So which screen do you want me to bring
on? The
receipt page?
The UI and the debug console.
Okay, no problems. I'll bring that up. Matt, can you, when I get this up, can you share my screen?
Yep.
All right, cool. Because otherwise I'll be sort of
And the documentation I did share about the handshake before was for V2. There is the V2 documentation for Greengrass.
That's the one that you dropped in there is V1.
That's what I'm saying. So there is a V2
Yeah.
link that I was
Oh
trying.
yeah,
Let me
I pasted
drop
that
this.
one in there too.
Yeah.
Oops, so this,
Yep.
I think I've just pasted in version 2. So this is how
Excellent.
how
Here we go.
Greengrass works version 2 documentation. So it does use the MQTT protocol that was discussed earlier. So it does the pub sub for MQTT, and then when you do the deploy, it actually receives a message to say pull down the install and deploy at the Lambda into the Greengrass group or onto the device basically.
Yep.
Okay, you can put my screen up, Matt, if you want.
Cool. There we go. So we've got the R&D Express page.
Yep. So on the left side, you'll see the R&D Express. On the right, you'll see the back end, so the admin console, and we can like mimic opening and closing the door here. Now, one of the problems was after the fridge that Josh will show in a second was set up and packed up from like Summit. One specific sensor was actually physically broken, so we'll have to mimic a slight little piece of it. However, I think Josh is going to run downstairs right now, and he's going to show us, like, you know, via his remote camera, what that fridge looks like and what it sort of looks like. So, are you downstairs at the moment, Josh?
Yeah, I already am. I've come downstairs.
Okay, Matt, can you unshare my screen?
Yep. And Josh, I can see your phone, but no image coming from it just yet. So I'm guessing.
Yeah, lost the window.
And I'd like a can of Coke if possible.
I can give you a Coke.
I thought Josh went and found Pepsi specifically for the demonstration.
So interestingly, the bottles that we had trained with the original machine learning model were we had a Starbucks Frappuccino, we had a very specific bottle of water that had like quite a unique lid, and it was basically borderline impossible to find those here in Australia. So I was in the US even just like a couple of weeks before Summit, so I brought some of those bottles back from the US with me to use with the model, just so we didn't have to train. You know, I don't think we were allowed to use beer at the Summit like I wanted to use, but
that was a multiple theme in like a lot of people's like talks. We swapped to drinks in general. I remember.
Yeah, like I wanted to use the beer bottle caps, right? Because they have a very nice logo on the top usually, so it becomes a little bit easier to train the machine learning model. And anyway, so I didn't bring the bottles back with me from Sydney, which means that I had to go and repurchase the bottles today. So Matt, I'm just going to spin my phone camera up here. Can you just tell me when you can see that?
Yeah, I'm just going to put it on the screen for everyone. We've got a bit of an echo coming through. Yeah, here we go.
Probably shouldn't, because I don't have the microphone enabled on my...
Oh, it's fixed now. Yeah,
okay,
it's sorted.
You can see the fridge here, right? I can't show you the devices necessarily because they're behind the fridge, but basically it's a Raspberry Pi with some GPIO pins hooked up, some wires coming out of the back of the fridge from the webcam, and a little relay that we use to enable and disable the magnetic lock. So with that, what I'm going to do is authenticate into the fridge using hopefully a username and password. And I'm getting a phone call here, so that's not great.
That's okay. Although it does look like we'll be coming over to try out this fridge at your house sometime, looking at
whatever's beside the fridge.
Yeah. Yep.
Okay, let me just log in here. So what I'm going to do here is I'm just typing my password into the fridge. I've hit the authenticate button, so you should be able to see on the screen somewhere.
The video is.
Do you want to show reshare my screen back again,
Okay.
Matt, and we'll show what's happened here.
Yep, you're up.
So we can see on the left side, Josh has come along. He's authenticated himself to this specific fridge. All of this is connected through sockets, so you're seeing this in real time. And there might be like a panel in front of the fridge, for argument's sake here, but it recognizes that Josh is there. Once he's signed in, what's happened is that Lambda function has been executed, which has said to the Raspberry Pi device on those specific GPIO pins, send a signal out, which is unlock the magnetic lock. So the door is now openable by Josh. And if you look at the back end, piece of this application, we can see that like a photo was taken before the screen was open, and then we should see in a second that our photo, here we go. So the photo has been taken a second time, and we can see that, yes, Josh has opened the fridge. Before he opened it, there was a Pepsi and a Coke, and we'll go through how that looks in a second. When he's closed the fridge, we can see that there's no longer a Coke in, and so the backend application has used its database to determine what was the difference from before into what was there after. Obviously Josh has removed, a bottle of Coke, and so Josh has been automatically issued this specific express receipt that says, you purchased 1 bottle of Coke for that. And so like this sort of shows what it looks like. And just to show the reverse of that, Josh, what I'll do is I'll click admin open. Do you want to put the bottle back in?
Yeah, sure.
All right. So just to show what this looks like this would be the same scenario if, someone was to authenticate. And even if somebody at home used the QR code, you could scan that QR code and we'd see something come up there on screen. But so admin is done. It's taken the photo before. Let me know once you've closed that door, Josh, and we'll see.
Yeah, I've closed it.
Yep. So we'll close that again, and we should see that it'll detect, the bottle going back in, and we should see like a -2. So here we go. So we've returned the Coke back in, and it's built that out there. This is a good example of this specific photo, Josh, and maybe talk to it about that specific model. So the inference is not happening on the device. The device is taking the photos and sending the photos up into that SageMaker model that we trained, right?
Yeah, exactly. So I think this is a good comparison, right? Before we mentioned that you could run this machine learning model on the edge, which is entirely possible. And I believe, Greengrass will allow you to have some of that capability as well. But in this case, one of the great things about SageMaker is it's pretty easy to deploy inference endpoints that scale, for you. So basically what we can do is we can create that endpoint, put an API in front of it, and it becomes very easy to just throw a bunch of images at it and process that all in the cloud. So, if you're ever worried about needing to have like large amounts of compute on the edge to actually do the inference, like it becomes very easy to actually just do that in the cloud with something like SageMaker. So in the use case we spoke about before with the video, generally speaking, if you want to decode video streams on the edge, you probably need things like GPUs, running locally in the store or on devices for wherever you want to do the inference, and that can get expensive at scale. So, there's always going to be trade-offs, but we just need to think about what's most appropriate for the use case.
Well, that would be like Amazon, NVIDIA Jetson Nanos and stuff like that, right?
Yeah, indeed. So
yeah.
Like with Amazon, with Panorama, there's different types of devices that will support Panorama. So you can buy, smaller Jetson or Jetson-ish types of devices, as well as devices that will allow you to use larger cameras. And, it's really about balancing the capital with the volume of data you need to process.
Yeah, because if this was on my Raspberry Pi, I'd be getting updates every 4 frames if I tried to evaluate what was in the fridge, let alone handling a stream of video somewhere else as well. So yeah, you definitely want GPU-driven edge devices if you were to do the ML on the edge. But there's little value in doing that. It would cost a fortune, as you mentioned, Josh.
For sure. I've got a good example. For example, I run DeepStack to do object and person detection for my home security cameras. And that definitely needs a GPU to kind of run that, so you can throw the video frames at it to do person or facial recognition. So it's just a good example of doing it locally versus doing it in the cloud.
Yep. Yeah. So, and if we is my screen still up, Matt?
Yeah. Yep. It's still up.
Yeah. So if we look at the right side of the screen when we see what's in the camera, what is making up the device that is making that? So obviously there's a fridge. At the top of the fridge, we've got in this instance, just a webcam is sitting at the top of the fridge, and it takes a photo before you open the door. So when you've registered, and then after you've closed the door, and works out the difference between them. So there's nothing, there's no specific complicated or difficult to use acquire hardware. This is something that somebody could do at home. Obviously, this is a proof of concept piece, but it's something that you could certainly do at home with. How much did the relay cost, Josh? A couple of bucks. A magnetic lock is probably the most expensive thing here, right? Yeah, and we've used relays in the stream before to go ahead and do that. But we did speak earlier about the specific how we made that training data for the bottles that are working here, and I thought that was interesting and something that maybe we could share. Do you want to take us through how that worked, Josh?
Yeah, absolutely. Let me just bring that up.
So do you want to share my screen, Matt, and let me know when that's done?
Yep. Done. And Jake just asked a question. What AWS team is responsible for making these projects? So
these have all come from various parts of Amazon, right? Let me just close the door. It's really cold in here. These have all come from various parts of Amazon, different teams demonstrating different capabilities. And what we've done here is just really curate them to tell a bit of a story about how they can be used in a retail context. So I believe some of the fridge was built by a team out of Brazil.
Mhm.
There was a team in the UK that built a lot of the code base for the Bopac demo. And then there was another one that we had, which was a customer 360 demo, which we haven't discussed today, built by another team. So, we're a big company and we've got lots of smart people all around the world. So we like to cross-pollinate where we can.
yeah, I think I know like the guy in Brazil that you're talking about. He's got like a combi van that is like completely IoT'd out. Is it the same guy?
It could be. I don't know
Yeah.
about his band, but he's part of one of the global prototyping team. So he often gets involved in very cool projects.
Yeah, it sounds like one and the same. But the other thing is like you've got solution architects and TAMs that work within the retail sector in particular. Like a lot of the time, we're aligned to different verticals. And so through what we call like the field communities within AWS, like a lot of people will be working on these types of things for their customers together and then sharing knowledge across that particular sector. So I'd say, Jake, programming, if you are in the retail space and you've got an SA or a TAM assigned, hit them up. They can definitely connect you in the right way, if not help you with prototyping themselves if you've got a particular use case that you want to talk through and have some validation on.
Paul, can you see my screen now?
Just share, like you're sharing like the StreamYard stream. Do you want to? Yep, here we go. So I've got your screen up now, Josh, at the moment.
So this was a notebook that was used to help train the object detection model using Amazon SageMaker. So one of the most important parts about training this model was actually building a data set so we could train the model. So to give you an idea, you obviously have let's see if I can actually find the photos, or maybe put them somewhere else. You obviously have, things that you need to tell the model that you need to show it what the models are. Sorry, I've lost the photo here. Okay,
We
so
can see that the bottle lid's up there.
you saw what the bottles actually look like in the fridge, right? So we need to provide enough examples to tell the machine learning model that this little red circle here against this background, this is what a bottle of Coca-Cola looks like, and obviously for Pepsi as well. So for every class of object that we have, we need to create a training data set to say, here's all of the examples and all the possible combinations of what this object will look like in the context of this fridge. So what we originally did is we actually took photos of all of the different bottle caps and the different things that we were going to train the object detection model on. So you can imagine here, like to do that, we actually took the photos just like they are here, but then cropped out just the lid or the thing that we actually wanted to recognize on. And then obviously, because we need such a large volume of training data, we didn't want to have to do that 10,000 times, which is probably the volume of data that we actually need to create an accurate model. So what we did here is we used a notebook specifically built for building a synthetic data set based off a few images. And we use Python libraries like CV2 and PIL or Pillow, also known as, to basically manipulate images into a very large number, so we can actually synthetically generate enough examples of the products to train the model. So to give you an idea, once we had 10 examples of each of the bottle caps, so you can see here that this is an orange iced coffee bottle. We also had, you can see here, iced chocky, which was another just simple lid. We also did another one. Let's see here. We did a lot of beer photos as well. So we trained it on Heineken and Stella and a bunch of other bottles. And then what we did is we took a bunch of images of the blank background as well. And then what we did is we actually used this notebook to create 1,000 examples of overlaying those bottle caps onto that background. So you can see here, we basically take one of the bottle cap images, and then we process it and put it over a background, random selection. And then we use Pillow to add a bunch of noise and reflection and glare and things like that to the photo to create lots of different examples. And then basically what we end up with is I can't remember which.
There's a famous TV show. If I sent Aaron the clip just beforehand, but Paul will know the context. It was like, I've only just trained my specific model for these 2 images. It's incredibly boring to have to train it for the 1,000 other types of food, right?
It honestly is. So you can see here, like we've taken the Coca-Cola bottle cap and we've just changed the size. So like depending on how tall and short the bottles are, will change how big the cap actually is in reference
Or
to
the shelf height. And
shelf
and also going back to what you said, adding in that synthetic noise, which is depending on the reflection of the sun at certain times of the day, whether someone's open or close the fridge, if something like a specific, like, I don't know, if it's at night and the headlight shone through the front of the shop, you might have different like light sitting on top of the bottle. So you want to like make sure that you have tons of examples of a bottle of Coke looking on top of this like specific shelf, thousands and thousands of sets of data. So like in this example, we're pretty much just using the cap, right?
Yeah, and you can also see like we've got plenty of examples here, and not all of them are good examples. We also want to see what the bad examples are, because we still need to match bad examples if the camera picks them up. So once we generated that data set, then we used another model, and really I think the underlying framework is a MXNet and ResNet based model and framework that we use to train the machine learning model. Which I'm not sure if I've got it in here. So once we did that, SageMaker, of course, helped us with the training. We can tune the hyperparameters. And then once that was done, we can actually go and test the inference of the object to see everything's working. And then, of course, we can go and deploy it to the inference endpoint. So that kind of just gives you an overall idea of how SageMaker can help you. And you can see here, we're just interfacing with the SageMaker API. And this is just how we can train models and deploy them to SageMaker.
Yeah, the good thing was like, that using SageMaker meant that we didn't need to install any custom libraries. You pretty much just open up those notebooks and off you go. You're ready to go. If you're familiar with Python, you can start to get moving. And I would say that neither like Josh or myself are machine learning specialists, but we were still able to work our way through all of these pieces. And there's plenty of examples out there of what that looks like and how, how to get going. So for anybody that was thinking about that.
We did stumble across a couple of weird bugs that took us a little while to work through, not just for the machine learning training, but also, Paul, we had a really weird one with the fridge function. I can't remember what it was now, but it took us a couple of evenings to. There
was always some like little intricate pieces there, and making sure that the ratio between the size of the bottle cap and the fridge was all right, because you don't want to just put a huge bottle cap over the top of the bottom of the fridge. So there was some stuff there that we had to do. So it was really fun. But we've like gone over time this week. So I think like having plenty of demos is really good. I knew we got one more, so maybe another time we'll do the personalized demo. But yeah, thanks everybody from the audience that's come along. Hope you all enjoyed that. Thanks so much, Josh, for coming and talking to us about like what you're seeing in that retail space, and showing us some IoT things. Any closing remarks, Josh, Matt, or Aaron?
No, thanks for having me. If there's anything here that you want to know more about, just reach out to Paul or myself, and yeah, happy to help.
No, it was awesome. Thanks for coming, Josh, this week. And I haven't checked the calendar for what's next week, but come join us the same time, and we're going to have something else. We always stream 12 p.m. AEST time every week. So I'm
always
sure next
fun.
week's going to be some fun IoT project or something. If not, it'll be continuing the chatbot that we worked on last week.
Continue our Lexbot.
Yep. Thanks everyone.
Thanks all. Take
Thanks,
care.
everyone.
Bye.
Cheers.
Bye.